Hey everyone, welcome to Spring One once again. I'm Jimmy. So glad to have you all here. Really excited for our next session with Oleh Dokuka and Anton Arhipov. Arhipov, excuse me, Anton. I'm so sorry. We're talking about multi-platform apps with Spring, Kotlin, and RSocket. So let's not wait around any further. Let's just jump right in. They've got an awful lot to talk about. So I believe we've got them here. Oleh and Anton, are you there?
Yeah, we are here. Can you hear
We
us?
are. We are.
Uh, Outstanding. Let's get right to it. Thanks for being here, gentlemen.
All right.
Thank you.
Good
Thank you
evening,
for the
everyone.
introduction. Hello. So we are going to talk about multi-platform applications with Kotlin and other technology pieces today. And we would like to emphasize the word multi-platform in this context. So this is going to be a presentation about different technologies playing on different platforms with the aid of, the programming language. Let us introduce ourselves a little bit. I'm a developer advocate at JetBrains. I work with Kotlin team, and I've been programming Java for years, and now I'm all Kotlin, spending time talking to people about Kotlin and presenting at conferences, writing blog posts and videos. And Oleg is a good friend of mine.
Hey, everyone, and good evening. I hope you already enjoyed the first day of this amazing conference, and you're warmed up already, and you're prepared for this exciting talk about exciting technologies such as Kotlin, Spring, and of course RSocket. You learn about RSocket from the previous day, from the previous talks, from Toshiaki Maki, from other awesome folks. And in this talk, we will continue to share the awesomeness of great technologies with you as well. So maybe let's start, Anton.
Yeah, so Oleg is the Mr. RSocket and I'm Mr. Kotlin today. And Kotlin is the programming language, as you know, that was designed for JVM actually for like 10 years ago. It's the 10 years of Kotlin this year. And it is very popular in Android programming, but actually it was designed to be used wherever Java is used. So server-side applications and, as a matter of fact, Spring is really well supported by Kotlin and vice versa. And the programming language itself is a multi-platform one. So if we talk about platforms, there's a different runtimes, in fact, and today we are going to spend time looking into those different targets with Kotlin, with our Kotlin application that is, built as a demo today. The thing we are talking today about is actually very, very experimental. So we are going to try science here. In fact, the reason I'm talking like this is that Kotlin multi-platform projects is still in alpha stage, and it's not going into beta sometime. Like I hope it will happen soon. But today the status is alpha, and it means that it's whatever we write in a demo application might not be true in a few months of time. But still, it's an interesting concept to learn about, and this is why we are doing this talk. So there's we have a playground. Let's look at our playground now.
Yeah.
Well,
So
it
yeah,
looks like a nice.
yeah,
Go.
this is basically the setup that we have, and you say, Anton, that let's talk first about the application that we're building. We're building today a to-do list, right? So this is a simple example. Like every one of us at some point in time built a to-do list at any language. So we want to do the same with Kotlin because we can. And on the other hand, the to-do list application can be an interesting source of example because to-do list can be local, but at the same time, we always want to share this to-do list with other people or with other devices. So, for example, we want to start at our desktop, then we want to switch to our mobile, or at some point in time, we want to access from the different computer through the browser to the same to-do list without setting up any additional application on the external computer or other computer. So, Anton, I'm just wondering how Kotlin can help us building all these things. So you say that with Kotlin we can enable all these platforms. Since you said multi-platform, so I imagine that Kotlin can be executed in all these platforms.
Exactly, it's possible since like Kotlin is multi-platform. We can run the build on some Kotlin code and decide, hey, I want it to be compiled into Java bytecode, or hey, I want it to be compiled into JavaScript. Why not?
So what can be common between all of them? Understand that, okay, some of the things can compile to different platforms. You say that Kotlin supports native compilation or compilation to JS or compilation to Java or whatever other platforms you support. So what can
exactly
you share?
Exactly. The thing is here, if we say that we are just using the language, why we decided to use to-do list as an application, like almost like a real life application, because there are some challenges, some small issues that we have to overcome while implementing this application on different platforms. We didn't want to just take an application, some abstract algorithm for sorting, and retarget it into multiple different platforms, because we actually wanted to show how Kotlin would play with the local ecosystem in a specific platform. Like if we develop for the backend, how does Kotlin play with Spring, right? It should integrate with some framework. If it's an application on the desktop, it should be using some sort of desktop or UI framework for building a desktop application, or Android SDK, or React, for instance, if we build a UI for the web. So we actually are implementing something very specific to the platform, and there is a correct question: what could we share between those different targets?
Yeah, let's start maybe from the simple. What can we share, for example, between front end and the back end apps? So let's start just from the simple example, maybe.
Well, I definitely know that the developers that who develop web applications, if we just take the back end and the front end, and there is often the separation of responsibilities between developers. Someone is developing the UI and someone developing the backend. And whenever the model changes, let's say you are building the to-do list, so we have items, to-do items, and those to-do items have attributes. And if we change the set of attributes for those items, it means we change the model on the backend, and we need to change the model on the front end again. So this is like the core problem that everybody has who develop UI clients and backend application in different languages. So if you have the same language for both for the backend and for the front end, you can actually reuse the model, and that's already a big win, right? So and the language actually gives us the tools for that. So in this specific example, we have a backend application in Kotlin and Spring Boot, and well, it means it runs on Java, right? So we will have model classes that we will compile to Java bytecode, and then we want the same classes, if we change something, to be reflected in our front end. So if we implement it in Kotlin JS, or even just in pure JavaScript, we want those changes from the backend to be reflected in the front end immediately. And the language gives us the tools to actually not just to transpile the code into different targets, but it also gives us the tools for overriding or like declaring some of the functions in the common code. Like, let's say we have a common function that calls a platform specific function, and in the code we will declare that this function is a platform specific one and should be implemented in some platform specific code So we declare it with the expect keyword, and in the platform-specific case, we say that it's an actual implementation with the actual keyword. That's a very simple example here, right?
Yeah, indeed. So we just mentioned that, okay, we can share some domain logic, some validation logic, maybe possibly some view logic if you want to implement something like very specific. I can imagine that something very specific for platforms can be UUID generation. For example, in Java we have like a built-in mechanism for UUID generation. So for in Java we wanna use like this tooling, but for other platforms we might want to use the other tools. Like for iOS it's another UUID generator. For JS we want to build something from scratch because there is no like built-in functionality for UUID generation in Node or JS or in browser. So it's clear. Yeah, so maybe let's start and look how this can fit into the real example. We just covered different parts of our application and just discuss how they can be implemented and which parts of the code can be shared. But maybe let's have a look at the real app and see how this can be enabled, for example, for other applications which has browser part, which has backend part with Spring, and maybe we can learn how this can be structured, what specific parts of the setup of multi-platform application we should be aware about. So let's talk about that.
Yeah. So the specific repository that Oleh has in GitHub, we started with a simple scenario when we only had the web application with the backend in Spring and the front end with React.js, both implemented in Kotlin. But we also, if you go and look into that repository, that's the main branch. But we also have another branch that incorporates the use cases for clients for Android and for the desktop as well. So it's a more sophisticated example. We are going to cover both of them today. So I hope if you were interested, you have copied the link, you have scanned the QR code, and let's look into the project structure.
Yeah, actually, just to use, I'm seeing some questions in Slack, and the folks are saying that, okay, they are using Open API for code sharing. I guess maybe it's not enough just to build something.
It's a very classical approach. Yeah. It's a very classical approach that you have some intermediate representation or description of an interface of an API that you can scan and generate some client code. That has been there for ages, like since .com technology, when you were describing the interfaces for your components for Windows. But we are talking here about cross-platform sharing of the real code that could be overridden in a platform-specific case.
I remember a good picture about the code, and the more code we have, the more bugs we have. So if you say, Anton, that Kotlin can reduce the amount of code we write, for example, the business logic or the algorithm that we can share, and write once, test once, and then share with all the platforms, then it should work.
As we said about those different examples, and we are going to reiterate on them a little bit later. Like domain classes are the most obvious case, but imagine the validation rules between the even in a very simple case when you have a front end and a back end. In the back end you may have the API, so you will have the validation rules in the back end, and you want a good user experience as well, so you could immediately reject some user input in the web UI. So you will have those validation rules populated across different clients and the backend. So if you change something in the backend, you want those validation rules in sync with your clients as well. And if you have those validation rules implemented in different languages across clients and different modules, there you go. You will have bugs, you will have errors, you will have out of sync validation rules and so on. And if we have the opportunity to redefine the logic in one single place, that's a great benefit.
Indeed. So let's maybe move on to the real code, to the core part, to the meat, and let's chat on how one can structure the simple application and have Spring Boot with, for example, front end collaborating together, sharing the same code base. So can you speak on that?
Yep. So if you go to start spring.io actually and generate some project, it will be pretty much the same, but we have complemented it a little bit with the multi-platform capabilities. So if you look at the very top part of the Gradle file here, you'll see in the plugin section there is a Kotlin multi-platform plugin and Kotlin plugin serialization, and we also have Kotlin plugin for Spring, but that's actually a default if you generate it in spring.io, so that's fine. But the essential part here is this Kotlin multi-platform plugin. So we have to use this plugin to actually configure the source sets, right? So if we go further, there are different targets. First of all, we say that, well, we want to generate the target code for those specific platforms. In this case, it will be the JVM bytecode, and we want some target, some additional target with JavaScript. In our case, it will be, using React module and the intermediate representation, the new backend for JavaScript, which is now beta, by the way. It was released just a week ago, and they pumped the status of Kotlin.js. And then we have to configure the source sets of the code actually in our project. So we structure it so that it looks like a single module Gradle project from the Gradle perspective, and inside that module we are using Kotlin multi-platform plugin to remap the directories in that project. And well, like if we look at the top, we see common main by getting. That's the configuration for common main directory. On the left in the project tree, you will see there is like common client main, common main, React main, and so on. So based on the technology, we restructure the project, and we may say that, hey, one part of that is the common module, right? And we are going to use that, and we are going to make other modules to depend on it, right, in this DSL. So we have a few source sets. If we proceed further, we are going to see that in those common modules, we have some code, some classes, some files that are actually common to all parts of our application, for the client and for the backend as well. And as we said, those are the domain classes, common interfaces that we implement, and some business logic. And let's look into that code and see actually how those language features are applied.
Yeah, absolutely. Let me quickly do that. First of all, yeah, that was good. Let's go to our IDE. So here's our project basically, and you folks seen and see right now exactly the same project as you've seen on slides. We have common client, common main, React, Spring main, Spring test, and the core thing is this Gradle setup that Anton mentioned. So we have it kind of implemented already to save our time, and here's all the bits. One important thing that I noticed is that, for example, if you're just Spring developer, as I do, I'm just doing Spring and Project Reactor. So I know a lot about Spring, and first of all, I'm thinking, okay, how would I set up Spring project, because this is a challenge. The answer is that, for example, if you're gonna go for your browser at spring.start.spring.io, the best place to start your production application. This is where everything comes from. And for example, you want to add your modules like RSocket. We will talk about RSocket later, reactive web, and so forth, and other important features for your web application, and so forth and so on. And for example, if you start exploring this project, you will find the place for your dependencies. And now if we go back to our IntelliJ and look at our dependencies for Spring, we will see the same set of dependencies. So you can put them, you can copy them from start.spring.io and put them here. And then if you want to configure your Spring application without thinking, how can I do that? What specific should be in for example, in Kotlin multi-platform setup for Spring, then the answer, nothing special. Just copy your plugins that you need to use, just copy all the tasks like as they are, and that's it. And you can put them into your JVM module that configures your JVM projects, which is Spring projects in that scenario, and put them over there, and that's it. And you can add more standard Gradle configurations, which is great. And I learned that it's really easy as pie, and you won't struggle on how to do specific things because everything as usual here, which is pretty good to me. All right, and then we wanted to look at some code sharing examples. So you may wonder, okay, what can we use as a communication protocol for our to-do apps, because we want to run one to-do in the browser. Then we want to make sure that all versions of this to-do list is updating like in the real time. So if we want to open multiple browser pages, we want to see like real-time updates between all of them. So this can be enabled, of course, with RSocket, because RSocket is real-time application protocol. Like, it's network protocol. It's like protocol for collaboration and not only. I'll talk about that a bit later. But here we have in common client main, we have some RSocket client setup. Don't worry if you see some compilation errors. This is fine, because as we mentioned, multi-platform capability is experimental, so it's okay that IDE sometimes may fail in recognizing all the required dependencies, which is fine. But the example of RSocket kind of code sharing and some functions that can be platform specific is shown here. For example, we want to have one setup for browser, right? So we want to make sure that for browser we create RSocket clients using specific engine. For example, we want to use KTOR here, and KTOR has KTOR client GS, which is specifically designed for using browser capabilities. And for JVM, we want to use, for example, OCK-HTTP. So we want to implement client using OCK-HTTP or NETI capabilities for JVM, for example. We will talk about that later, and we will see how that all play together. But right now, we have one implementation of this expect function, which is for GS. And here we see that, for example, we are using KTOR, which uses HTTP client, which setups WebSocket and installs RSocket support. And then, for example, we use specific browser capabilities like window.location host, which is not available in all other platforms, only for browser. Even in Node.js, this is not available. So this is a great example of how you may, for example, set up your specific configurations of your client for browser, for example, then for Node, for backend, and all of them will be available only for a specific platform, as far as I understand, right? Okay.
Correct.
Yeah. So what else should I show? All good, Anton, or should I spend some time on something else?
Maybe we can show the client code, this client class as well, so just to show that it's the main object that
moves. We have like all to-dos, repositories, and all the services that we shown. And actually, to-do service is a great example of simple algorithm or service logic that you can share between all the platforms, because this to-do service is actually used on the backend side, inside our 2D controller, which is just standard Spring controller designed for RSocket, like controller, message mapping, and all this stuff, like standard, really popular configuration and programming model is available for RSocket as well in Spring. So please use it. And here we use this service capability to handle events, and at the same time, as far as I remember, we are using the same capabilities and the same features on the GS side. So yeah, here we go. We create to-do service. We provide a bit different implementation of our to-do repository. So for GVM, it's like in memory, or it can be database repository. For GS, for browser, we are using local storage, like in-memory browser store, like the Chrome store or whatever other browser store, to store the information related to your session. So we are using it to store your data, to store your to-dos, and enable you to run your browser app in offline mode as well. So, right. Yeah. Here we go. So
that's exactly the example of business logic that you implement once and use in different platforms.
Correct. And then, yeah, basically all the UI, you can see some components which are using React, and yeah, you have to be front-end developer to know all the things. I'm not familiar that much with all this stuff, but as we can see, they all are written in Kotlin, and Kotlin, even for React, provides some wrappers which allows you to feel this kind of browser
Correct.
native development. Okay, so let's move on.
Let's go back to the slides.
Maybe first we have to look to the app, or should we look at it later?
If you have it running.
Yeah, of course.
Do you have it running? Yeah, like quickly show people this nice application, bleeding edge.
Yeah, let's first open 2 different windows and get access to the same, to the same view or similar view first. So let me place it over there, one tab here, one tab there. And now let's see if magic works. Magic. It works. Magic. So if we're gonna edit, we will see that it updates simultaneously. And yeah, as I mentioned, we are using RSocket here. So before we start talking about RSocket, let me just ensure you that it's really RSocket. So you know already from the previous talks that we have RSocket frames debugger, and here we go. We have all RSocket frames, of course. The tool is bleeding edge as well, and it's not yet ready for my dark theme. That's why you see a bit of clunky frame view, but it's okay. You can see that there is fire and forget, there is request stream, which is sending multiple messages, and just to ensure that this is real-time communication, we can see WebSocket and binary messaging coming back and forth. Okay, so let's go back to slides. And let me talk a bit, or do you want to summarize what we've seen?
Yeah, basically, if you go to the next slide, I have an idea that I wanted to say when we were building this demo application. I thought that Kotlin is the essential part there, but well, Kotlin can compile to different targets, but you need libraries to actually enable this, and this enabler in our use case, in our demo application, is RSocket actually, because we need a multi-platform implementation for the protocol, and that's RSocket.
Yeah, absolutely. And actually RSocket have full compatibility with this word multi, because it has, first of all, many features which enables usage of RSocket for multiple purposes. For example, it supports multiple different transports. So you may write your logic once, write logic once, share it with different transports in that scenario, because it can run on top of TCP, it can run off any UDP based transports like Aaron, or we will support Quick shortly, or like if you want to run it over shared memory, you can do that as well. Nothing prevents you to to kind of to stop on specific transport implementation. It brings multiple transport supports. On the other hand, it supports multiplexing, so multiple requests can run over the same connection, which enables performance. Then it supports multiple interaction patterns. What does it mean? For example, in HTTP, the most common communication pattern as of today is request response. And unfortunately, you may get more like some one-side streaming with server-side events, but this is not kind of, it's standardized, but this is not something that was built into HTTP from the very beginning. In RSocket, we have multiple interaction patterns, which enables you for streaming, for bidirectional streaming, for request response communication, for fire and forget communication when you just want to push a message and forget about end response and forget about waiting for this response at all. So this brings a lot of flexibility and sharing of the same library for multiple purposes. So you don't have this RSocket to use HTTP and then think, okay, how can I utilize another library which supports WebSocket? RSocket already enables all the things. And the last thing is that RSocket is multilingual or polyglot protocol, which is implemented in multiple platforms, but even more, it's implemented in Kotlin, in multi-platform Kotlin. So we have RSocket Kotlin designed from very beginning to support multi-platform capabilities to run on top of different platforms, various, including iOS. So RSocket with Kotlin is a real power. That's all that I can say. So yeah, the last thing we kind of covered, Anton, this awesome demo with you. We looked at, okay, we can set up Spring app and browser app. This is the most common setup because most of us are building like enterprise applications and we are using Spring and we are using browser to demonstrate what's going on in our enterprise application. And RSocket improves a lot of things and enables a lot for us for enterprise applications as well. But what about mobile apps? Because I want to sometimes to access my to-do list from my Android phone from here, or for example from my desktop app. I want to have in my desktop macOS, for example.
That's
native
totally
applications.
legit requirement. I mean, today all the apps should be built with mobile first in mind, right?
Yeah. So can we support these two platforms as well?
I think so. Let's look into that. So, but the thing is, when we started to building it ad hoc within the same demo project, we realized that, oops, the multi-platform projects can't really incorporate Java plugin and Android plugin together within the same module, within the same Gradle module. So we actually had to restructure our project a little bit into a multi-module Gradle project instead of multi-platform Kotlin Gradle project. So we moved from one Gradle module into multiple modules to isolate the Java plugin and Android plugin, to have them in different Gradle modules. But we still have multi-module, multi-platform, too many multis today. But we still have multi-project set up in the shared part. So we have a shared module that generates the common part of the application and generates the different targets of that common module as libraries, as dependencies for the other modules in our Gradle project. And in fact, the result is the same. We still are using the domain classes. We are still reusing the common interfaces, pretty much like not pretty much all the same code that we are reusing in our initial version is transferred into this new version. And we can reuse the same code for Android application and for the desktop application as well.
So technically nothing has changed. The only difference that we have to create multiple modules, which is totally okay. We got used to monorepo before, and it shouldn't be a big problem to me, I think. And yeah, as I understand, Android is a specific platform which requires you to follow their structure, which is fine. We can allow this. So maybe let's have a look at the source code and see the difference.
Yep.
All right, so here is the previous project, and yeah, just to save myself and Anton from the failure, to be resilient. Yeah, the main rule, to be resilient, to be isolated. We have two different projects isolated from each other and open already to prevent any failure, because ID tends to index the world every time, so we want to make sure that the world indexing won't happen right now. So we have this second app already prepared, and first of all, let's have a look at our build Gradle KTS. So far it's pretty simple, but it already brings some important kind of plugins into the class path, which is Gradle, Kotlin plugin, which is Kotlin serialization to enable serialization of code of the same projects on the multiple platforms without seamlessly. It's Spring platform plugin, which brings Spring plugin with all open classes, and basically Android build Gradle plugin to enable Android compilation here.
You need to show the settings Gradle.kts here to actually, to give the folks understanding that we are just including the modules here, and we have a multi-module Gradle project instead of, multi-platform Kotlin project.
Yeah. So as you can see, friends, we have just the standard multi-module setup, and we include different various of projects, and you can do the same at home or at your production applications, just to bring more feedback for Kotlin folks and for Kotlin multi-platform team. And then let's have a look at shared code. So the share build Gradle KTS, for share modules, is exactly or almost the same as we've seen it before. The main difference is that we don't have specific platform setups or application specific setups here. We just have standard declaration that we have Android, that we have JVM, and that we have JS for browser, and nothing else, nothing more than that. And then we have source sets, which kind of bring in required dependencies or common dependencies, which could be datetime, UID, serialization, coordinates, some test common dependencies, and then the same setup of modules like common client main with RSocket Kotlin, with RSocket transport Ktor, some GVM dependencies, because on the GVM we want to use, for example, Ktor client CIO, which is a native non-blocking engine provided by Ktor team, but at the same time they support netty, so you can run Ktor on top of netty. For JS, client JS, and for Android we use Oak HTTP and Android client, which kind of play well together. And yeah, this is basically all the shared code. And apart from that, we have the same setup, the same interfaces. The only difference is that all kind of function declarations, we expect that for example, this specific function which creates our socket client will be declared for all the platforms. So this expectation has to be satisfied within this shared module, because when we start kind of extending or following or using depending on this shared module in other specific platforms like Android or backend with Spring or browser, this expectation will have to be satisfied and pre-compiled already. So you have to get in the browser only JS binaries for Android only Android JVM binaries, for backend only backend JVM binaries, and nothing else. So we have to satisfy all this expectation within a shared module. And as you can see, we have them already satisfied. So for example, for JVM, we are using HTTP client, but we specify that we want to use CIO engine here. And apart from that, the setup is kind of identical, since it's KTAR and it's also designed for multi-platform. So technically or theoretically, we could move this away into some common, but yeah, we decided to keep it separately because maybe we want to use some specific platform features. Then
so the result is that from this shared module, we will actually produce dependency for each specific platform, for each specific application that is going to run on a target platform.
Yeah, exactly. Yeah, let me just finally show the Android, just to ensure everyone that the setup is almost the same, except that I'm using like static kind of API to access from Android emulator to my Spring Boot app. And then nothing special apart from that. I guess the only problem that we can notice, if for example, if we're gonna run all these applications, and I'll do that in a sec. So here we have one and browser applications. Here we have, where is that? Another browser application. I'll keep it over there to just ensure everyone that this is still working. And now I'm gonna show you the Android app. Okay, it's crashed. Oh no, it's working. Perfect. Yeah, it's working. So we have Android app, and we have desktop app here as well. So we have multiple different platforms, multiple different targets like Android, desktop, and here we use like Tornado FX, which is a wrapper, Kotlin wrapper on top of JavaFX, and we have two browser apps. And now, how we can ensure that they're multi-platform and they're still play together? For example, we can mark all the tasks as done, and we can unmark in Android one, and the browser another, and we can edit here text, and we can see that all of them got these updates. And this was enabled with Kotlin, with RSocket Kotlin, with streaming support in RSocket, and real-time communication. This is awesome. However, I started talking about the problem. The problem here is in the browser we have one view, which is supported by React. In the Android we have absolutely different views, so absolutely different experience, right? And in the Tornado FX we have yet another different view, and as everyone can see that this button is not yet supported in all other platforms, only in Tornado FX. So only in Tornado FX we can mark all the tasks as done simultaneously. So the main question is, can we support all similar views, or can we share views between all the platforms?
That's a good question, actually, and that would mean that we need a toolkit, that we need a UI toolkit that is, multi-platform. Like in our case, we have RSocket, which is, multi-platform and can be used from Kotlin. We need the same toolkit, or like not exactly the same as RSocket, but we need something that could be compiled, or the toolkit should work, or the API should, be capable for different platforms. And in theory, today, it actually exists. We haven't had the chance to actually play with it for this time, but I think we can implement the UI with Jetpack Compose on different platforms. It has been in beta for a while, and in this year, I think in May, they released 1.0. So it's a stable technology. It's very popular in Android development already today. There are production apps implemented with Jetpack Compose, and it's developed by Google for Android, of course. But JetBrains is also working on porting this toolkit into different platforms so that you could write the same UI, same layout logic, and compile it to different targets. In this case, we have Compose for desktop. You will implement the same layout for your Android application, and it will be working the same way on the desktop. And there is also Compose for web. Both those implementations for desktop and for web are currently, very early in very early development. The Compose for desktop is in alpha stage, and Compose for web is even more experimental right now. It's a technology preview. There are no binaries, there is no tooling yet, but you can go and play with the samples in GitHub repository. It's a very interesting project. The programming model in Jetpack Compose is also very interesting. It's a compiler plugin for Kotlin. I hope it will actually let us implement very nice usable UIs for our future applications.
Yeah, actually we have like a beginnings of that, and I can quickly show everyone how it may look like. So let me open another isolated project that we just kind of started, and show that in this Webpack Compose, not Webpack, sorry, with Jetpack Compose, Webpack, Jetpack, sounds pretty similar, Maybe there is
a lot of packing.
Yeah, a lot of packing. So we have common, and this common right now shares common UI. So we have different kind of components implemented using Jetpack Compose, and all of them are used in multiple platforms. So for example, Android source code looks like right now very thin, like definitely really thin, because you have just to-do root component, which of course brings other component into play, but the main UI just have one root component port into activity, and then everything is defined in the common. And the same is for desktop. For example, application, we have desktop, and desktop app has only a single activity which ports the same root content, as you can see here. So the same identical setup. And for GS we have almost the same. And I have already kind of run in this application, so let me open the Android preview of this app. So here we have Android. It's not already finalized, that's why we say that this is really experimental. But I just want to give you a feeling of how it looks. So we have this UI. Now just remember it, and now let me run, for example, a desktop app here, and you will see the identical UI. So it's running, of course. Here we go. You see, 1-to-1. The same UI, the same shortcut, the same great experience, and shortly this will be implemented and enabled with RSocket to have like collaboration capability as well. Okay, so nice. let's finish our talk. We're getting to the end, so let's summarize.
Yeah, we were able to implement a simple application first, with the backend and the front end in the webs, and RSocket was like this small enabler for us to share the code. But we were unable to actually use the same project structure for other clients, so we had to restructure the project, but we still can reuse the same code between the different modules. And that's a great thing, right? And in the future, well, hopefully the UI can also be shared. It's a very experimental stuff, but it's always interesting to play around with this kind of things.
Yeah, and just final word. Actually, if you are pretty new to Kotlin and you still wanna learn about how to use, for example, Kotlin in Spring, we have a tutorial for you. Let me just find this slide with tutorial. We skip
Right,
it,
it
but
uses Spring and it uses React, I think, and it uses RSocket as well.
yeah. So not this one. This is collaborative. This is why RSocket, and here is not here. Oh, here we go. This is a tutorial. So if you want to learn about Spring playing together with Kotlin and Kotlin coroutines and RSocket, you may start now, and later on we will bring you much more full multi-platform with RSocket and much more features. So start from here today, and later you will see more. With that, thank you for your attention, and we are looking forward to get more questions from you into Q&A room, which is following right after this. And don't forget to follow us with Anton on Twitter. Like it should be identical to our names. Like mine is like at Oleh, then Dokuka immediately. And yours is Anton Arhipov, or it's different?
Exactly the same.
Exactly the same. So follow us on Twitter, don't forget, and ask about RSocket and Kotlin multi-platform there.
Well, thank you very much to Oleh and Anton. Wow, a font of information there. Great stuff. No doubt you will have questions, and if you do, feel free to use the accompanying Zoom link. They're going to be available for you in a Q&A session, I believe right now. So if you hit that Zoom link, you'll be good to go. All right. Thanks everybody. The next session is coming up very soon.